Today we are going to begin a new unit, our third unit of the semester. This corresponds to Chapter 6 material. So that's what we'll be following along in our book. It's rational exponents and radical functions. For this first lesson, corresponding to section 6.1, our goals would be to complete the following. Rewrite expressions in rational exponent and radical notations. Evaluate the nth root of a given expression. So we're going to explore roots other than just square roots in this chapter. So radical notation. Radical notation is the root sign. The box that right here is going over the root that we call square root of 2. The root indicates it's in radical notation. Okay? If we want, we've done this before, radical notation, square root. But what does it mean? We can write this as rational exponent notation. In other words, instead of as a root sign, we can have it as 2 to some power. So square root, what would that be as a rational expression? It would be 2 to the 1/2 power. This is the cube root. Cube root because it's power of 3, or a root of 3. To rewrite that as a rational expression, it would be 2 to the 1/3 power. And down here, we stop giving them fun names, and we just call it a really unique name, 4th root. And we rewrite that as 2 to the 1/4 power, and so on and so forth. 5th root, if you keep going with this if we want to, but we're going to stop here, 2 to the 1/5 power. So these expressions are equivalent. The 5th root of 2 is equivalent to 2 to the 1/5 power. So here are some rational exponent expressions, or something raised to a power. We're going to rewrite these in radical form, so with a root sign. So 2 to the 1/3 cubed. We're going to apply our power rules that we learned already in previous units. This would be power of the power, so we would be 2 to the 1/2 times 3, or 2 to the 3/2 power. And if I want to rewrite this as a radical, here's the deal. The denominator of the fraction, that's your root. So second root or square root of 2 cubed, or the square root of 8. Be rewritten in radical form. You could leave it as 2 cubed inside, but normally we would evaluate 2 to the 3rd power. Okay, we don't need to put a 2 up here because square root is implied without the 2. And we don't have to. If you put second root, it's the same thing as square root as before. Let's try it. If you think you're good to try these, go ahead and pause them, and then just turn the lesson back on when you're ready to check your work. This one would be 3 to the 4/2 power, or 3 squared, because we can reduce that fraction. No need to put it in radical form. It's just 9. 3 squared is 9. 7 to the 1/6 to the 5th power would be 7 to the 5/6 power. So it would be the 6th root of 7 to the 5th power. You can put that in your calculator to see what that number would be. And 7 to the 1/4 power would be 7 to the 9/4 power, or the 4th root of 7 to the 9th power. And we can evaluate 7 to the 5th and 7 to the 9th in our calculator. I'll leave that for you. So now we're going to go the other way. We're going to have a radical expression, and I want you to rewrite it using rational exponents. So let's reverse this. Let's look at example A. The 4th root of 2 to the 3rd power. The root is the denominator. 2 is inside, so that's the base. So 2, 4 is the denominator because that's the root, and the power outside here, 3, that's the numerator of the fraction. So 2 to the 3/4 power. Okay? Another way, if you want to pause this, go ahead and be ready to check them, come back. So another way to look at this is the square root of 3 to the 5th power. You can also say, well, that's just 3 to the 1/2. The square root is 3 to the 1/2 to the 5th power, or 3 to the 5/2 power. For me, the first way we did it in A is just faster. Knowing that the power outside the numerator is the denominator. Of course, you would simplify it or reduce the fractions if you can. Last one, 2 to the 2/3 power. Okay, so that's just working backwards. Now we can verify these in our calculator real fast. How do we do that? Let's look at the first example. So we have the 4th root of 4th root of, oops, let's delete that, try that again. So first we go to math, and now we want to do roots other than square roots or cube roots. We have to choose number 5. So the 5th root, we don't want the answer. Let's go up there and put in 4. We want the 4th root of 2. We want to put the whole thing in parentheses, so let's go back and add parentheses here, just like we had it written out there, example. So insert a parenthesis. 4th root of 2, all to the power of 3. We're going to get some decimal. Now, is that the same thing as 2 to the 3/4 power? 3 divided by 4 and the power divided by 4. We get the same value. That proves that we have the same thing. So this is just a way to check it when you're done. I'm not going to do it for all, but I suggest you do on your homework and, for your quizzes, especially tests, etc. Okay, so I'm going to ask you to evaluate various expressions. That basically means simplify them as much as you possibly can. 4 through to 16 to the 5th power. Well, what is the 4 through to 16 in your calculator? Practice that like we just did in the last problem. It should be 2 to the 5th power, which is just 32. 128 to the 5/7 power. You could put it directly in your calculator, or you could rewrite it. 7 through to 128. It multiplies by itself 7 times to get 128. That's 2, which is to the 5th power. It once again 32. And the cube root of -8, we can do that. You can take odd roots of negative numbers. It's not imaginary. This is just like -8 to the 1/3 power, all to the 5th power, or -2 to the 5th power, which is -32. Double check those, put those expressions back in your calculator, make sure we did them correctly. Solving equations with roots. Okay, if it's an even root, you're going to have a plus-minus situation or 2 solutions, plus-minus. If you have an odd root, it's just positive or negative, whatever it comes out to be in your calculator. So for A and B, there's just going to be one solution when we solve this. One solution. And then down here, there's going to be 2 solutions, plus minus, because it's an even root. Okay? So how do we go about solving these? We got to isolate the variable first. Divide by 1/2 is the same as multiplying both sides by 2. 512 times 2. What is that value? 512 times 2 is 1,024. So x to the 5th equals 1,024. How do we get rid of that 5th power? To cancel it out, we take the 5th root of both sides. 5th root of something in the 5th power cancels it out. Or you could raise both sides to the 1/5 power. It would be the same thing. In your calculator, I'll show you one more time in case you were confused. It's sometimes easier to put the root in first before you select Math 5. 5th root, yeah, it puts it up there for you. 1,024. It's just 4. So our answer is 4. We don't have to do plus or minus because it's an odd root. How about 2x to the 3rd equals 128? It's going to be the same thing. Divide by 2 to the 3rd root. Let's go down to C here. I'll leave that one for you. Let's try doing C together. The divide by 2 on both sides. 14,500 or 1,458 divided by 2 is 729. To get rid of the 6th power, we take the 6th root. It's an even root, so we're going to have a plus and minus answer. The 6th root of 729 is 3. So there's your 2 solutions. Solve it. Okay, so negative rational exponents, what's the difference with those? We're still following the same power rules we had before. If we have a negative exponent, that means it flips to the bottom or to the top, depending on where it starts out. The negative 1/2 would flip 4 to the 1/2 to the bottom. So 4 to the 1/2, that's just the square root of 4. Which the square root of 4 is just 2. So this would simplify to 1/2. If you want to try the rest of these, pause it and then come back when you're ready. So this would flip to 1 over negative 125 to the positive 2/3, which would be the 3rd root of negative 125 all squared. The 5th root of negative 125 is negative 5 squared, which is 25. So 1 over 25. You, of course, can put this in your calculator and hit math fraction when you're done to double check your work as well. And I strongly suggest that, especially if you're lucky enough to get one of these with just numbers on a quiz or a test. 1 over 8 to the positive 4/3, that's what this would be, which is really the 3rd root of 8 to the 4th power. The 3rd root of 8 is 2. 2 to the 4th power is 16. So 1/16. So did we evaluate these or accomplish these goals? I believe we did. We did rewrite expressions and we evaluated various roots of a given expression. We'll have more practice tomorrow in class. Bring your notes ready to be checked, and we'll see you tomorrow.